In this video, since we just talked about solving polynomial inequalities, we're going to talk about solving a polynomial function in terms of an inequality. So this says for f of x equals 4x to the fourth minus 4x squared, find all x values for which f of x is less than or equal to 0. That's basically the same thing we did, because f of x equals 4x to the fourth minus 4x squared. So if we replace this f of x with the polynomial 4x to the fourth minus 4x squared, we want to know when those values are less than or equal to 0. So we have everything on one side already, less than or equal to 0. We need to factor. We always start with our GCF when we factor. So I'm going to pull out the GCF of 4x squared. What's left when I take that out? A 2, oops, no, sorry, I lied. I took the 4 out. An x squared minus 1, right? 4x to the fourth divided by 4x squared is x squared. And negative 4x squared divided by 4x squared is negative 1. Now I'm not done factoring. When I have two terms, I have to look for sums and differences of cubes or differences of squares. So this is a difference of squares. I need to keep factoring. It'll factor into conjugates, so x plus 1 and x minus 1. So what are my critical points? What are my intercepts here? So I have to set each factor equal to 0. So 4 is technically a factor, but 4 cannot equal 0. X squared is a factor. And when I square root both sides, it just means x could be 0. And x plus 1 could equal 0, which means x could be negative 1. And x minus 1 could be 0, so x could equal positive 1. So I have 3 critical points here. I'm going to look at, or I'm going to plot those, negative 1, 0, and 1. I notice that I have 1, 2, 3, 4 regions that I have to test. So I'm going to test something less than negative 1. How about x equals negative 2? Plug it in. 4 times negative 2 squared minus 4 times negative, to the fourth there, squared. I want to know if that's less than or equal to 0. So negative 2 to the fourth power is going to be positive 16. And positive 16 times 4 is going to be 64. And then negative 2 squared would be positive 4. Positive 4 times a negative 4 would be negative 16. And then when we subtract that, let's see, we'll get 48. Is 48 less than 0? No, that's false. So that's not part of our solution set. Something between negative 1 and 0. Well, it's unfortunate, but we have to do a fraction here. There's no other whole numbers between negative 1 and 0. So I'm going to test x equals negative 1/2. That sounds like the easiest fraction I could think of. So replacing x with negative 1/2 to the fourth minus 4 times negative 1/2 squared. Is that less than or equal to 0? So negative 1/2 to the fourth will be positive. 1 to the fourth is 1. 2 to the fourth is 16. Right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. minus 4 times negative 1/2 squared would be positive 1/4. And then I can simplify this before I multiply. That's a 1, that's a 4, so I'll have 1/4 minus, that'll be a 1, that's a 1, so minus 1. 1/4 minus 1 is negative 3/4. So is negative 3/4 less than or equal to 0? Yes, because it's negative. So that is true. All of this will be part of my solution set, and because I have that equal to bar, I will go ahead and include those in my solution. Then I have to test something between 0 and 1. How about we do the positive? So x equals 1/2. I'll end up with 4 times positive 1/2 to the 4th minus 4 times positive 1/2 squared. And guess what? I'm going to get the exact same values. So what's going to happen is, because this was negative, but to a 4th power, I ended up with positive 1/16. So positive 1/2 to the 4th power will still be positive 1/16. So this will be 4 times 1/16, and positive 1/2 times squared would still be positive 1/4. And we already did all these values. 4 times 1/16 is 1/4. 4 times 1/4 is 1. And then 1/4 minus 1 was negative 3/4. Was that less than or equal to 0? That was true. I don't have to do those values again. I already did them over here. Because once I take the 4th power and square it, I end up with the same values. And I already know that that was true, so this will be true also. So here's what I said before, remember? In the last video I said, in general, it'll go true, false, or in this case, false, true, false, true. But look, I tested it, and these regions were both true. I'm going to go ahead and erase that bracket because I don't need it now, because this other region was also true. So I'm hitting all these values in here. And I need to test my last area. So something greater than 1, I'm going to pick 2. 4 times 2 to the 4th minus 4 times 2 squared less than or equal to 0. This is going to be the same idea. I did negative 2 over here, but I took it to the 4th power and it became positive. I did negative 2 squared and it became positive. So using the positive already, these are going to end up being the same values. I'll have 16 times 4, which is 64, and 4 times 4, which is 16, and I'll end up with 48, and that will also be false. 48 is not less than or equal to 0. So this last region doesn't work. So the final solution set would be from -1 to +1. I'm not going to break it up into 2 separate regions because I'm hitting everything from -1 up to +1. So essentially what's happening is this is one of those ones where it's going to bounce off of the x-axis and continue being less than or equal to 0. And there you have it. So if you have a function and you want to know if that function is less than or equal to 0 or greater than or equal to 0, you just plug in the polynomial that it equals and then continue on the way we did in previous videos.